Alright guys, so let's finally actually use the simplex method to maximize one of these problems. Alright, now notice this is the same problem as the one from the beginning of section 6.1, so let's revisit it again. Alright, we've already converted that guy to a system of equations and we wrote out our initial simplex tableau. Alright, so what we can do is we can talk about how to move within our tableau. All right, so if I have finished and I have found the optimal solution to a simplex tableau, we're going to have that all of these entries right here are positive or zero. All right, now if that is not the case, we know we still got work to do. So if there is an element in the bottom row that is negative, I am going to select my pivot column, and that is going to be the column with the most negative entry in the bottom row. So if I have -5 that's bigger than -4, there is my pivot column. Now since that column corresponded to our x1 coefficients, that means that my entering variable is x1. All right. As far as my pivot row, I will create from my pivot column a ratio for each coefficient or constant to my number in that column. All right. So 18 divided by 3 is 6, 10 divided by 1 is 10, 2 divided by -1 is -2. The pivot row is going to be the one with the smallest non-negative ratio, right? So -2 technically is smaller than 6, but I want a non-negative number, all right? And that means that my pivoting element is going to be 3 there, all right? Now, just some terminology from your book as well. This S1 here is going to be my exiting variable, and that is because right here I have that 1 at the top of the column with all zeros in it. So if I find the pivot row, I'm going to go through here and figure out which one in this row has the 1 and all zeros with it in that column. That's going to be my exiting variable. Okay, so there's 3. So our pivot element is in the 1, 1 position. All right. In a pivot, the pivot element will be changed to a 1. All right, and all entries above and below will be changed to zeros. This can be done through a series of row operations or with the pivot program. Okay, so you guys have the book to look at as far as how to do one pivot. All right. If you have clicked on the calculator tab in your homework and you have downloaded the pivot program, all right, I'm going to show you here how to use that. Okay, so we are going to go into our calculators. I'm going to clear out everything else that I've got, and I need to go to matrix. All right, now I'm going to go over to edit, and I want a matrix that is, it looks like 1, 2, 3, 4, 5, 6, 7. Oops, I went backwards, didn't I? 4 by 7, right? So 4 by 7. And I guess I could have cleared this guy out, but it doesn't matter. All right, because I'm going to go through and hit 3 and enter that, 2, enter, 1, enter, 0, 0, 0, 18. And then 1, 2, 0, 1, 0, 0, 10. -1, 1, 0, 0, 1, 0, 2. And finally, -5, -4, 0, 0, 0, 1, 0. Now, your pivot program is only going to work off of matrix A. So whatever you have stored in matrix A is what it will pivot. But I am going to go to Program, PRGM, hit Enter on my new pivot because that's the program that we use. Enter again. All right. we are going to hit enter on pivot. And because my element that I am pivoting off of is 1, 1, that is in the first row, 1, and first column, 1. So from that, it will give me this. Okay? And I'm going to go ahead and flip it over to my next page. Now, what you see here is obviously hard to read. Now, as long as we don't hit enter or go any further, we can scroll around in this guy without messing it up. All right, we can look up, we can look down, it's going to move around, and I can actually write it all out so that I get this. Okay, now that we are done,